Hey everyone, as an astrophysicist, I spend a lot of time thinking about what's going on deep inside other planets. And today, we're going on a journey deep into the heart of these frozen worlds to uncover a kind of ice that is so strange, so alien, it's completely rewriting the rulebook on how planets even work.
Just imagine for a second a world with a vast, hidden ocean churning miles beneath a thick crust of ice. And these oceans are powered by a force we are just now starting to wrap our heads around. We're talking about a type of ice so bizarre it can actually generate a planet's magnetic field. Yeah, it's completely rewriting the textbook on planetary engines. All right, so here's our mission briefing. First, we'll dive into the mysteries that are plaguing the icy worlds right here in our own solar system. Then, we're gonna go way beyond the simple snowflake to understand some really exotic ice. We'll uncover what I like to call the critical salt factor, explore the mind-bending shift from Ice VII to Ice X, and then finally, we'll see how it all pulls together to power an alien planet. Let's start the descent. Our first stop on this journey is a puzzle that has had planetary scientists scratching their heads for decades, and that is the mystery of the ice giants. So when we look out at planets like Uranus and Neptune, something is just off. Their magnetic fields are totally bizarre. I mean, not at all like Earth's, which is pretty nicely lined up with its spin. Theirs are all skewed, tilted, way off center. And that weirdness? It's a huge clue. It tells us their magnetic fields probably aren't coming from a molten iron core like ours is. The engine must be something else entirely. What could that engine possibly be? Well, to figure that out, we have to go way beyond the simple snowflake. Because believe me, this is not the kind of ice you find in your freezer. Our sponsor, Mathix, is all about that, but for mathematics. They make learning fun and easy, with cool features like AI support that really helps you get it. You can check them out using the link right there on your screen or down in the description. Now, when I say ice, you probably picture a snowflake, right? But get this, that's just one of more than 20 different kinds of ice that scientists have identified. Under just the right conditions of temperature and pressure, water can twist itself into a whole family of exotic ices. Okay, let's put this side by side. On the left, you've got the ice we all know, Ice H, with its light, hexagonal, kind of honeycomb structure. But over on the right, under pressures more than 20,000 times what we feel here on Earth, water molecules get crushed into something totally new, Ice VII. It's got a dense, cubic lattice structure. And you can really see that dense structure right here. Just imagine the water molecules being forced into this super tight, ordered grid, almost like the little cubes in a Rubik's Cube. This compact arrangement is what makes Ice VII so incredibly dense, and it is the absolute key to what's happening deep inside these alien worlds. Okay, so we've got immense pressure and this exotic ice. Those are two big parts of the puzzle. But there's a third, secret ingredient that just changes everything, and that ingredient is salt. You see, the water deep inside these icy moons and exoplanets, it isn't pure H2O. Nope. Just like our own oceans, it's salty. It's full of dissolved minerals like sodium chloride. And this one simple fact has massive, massive implications for the physics of what's going on way down there. This graph right here shows you just how powerful that salt is. The blue curve, that's pure water. You can see as the pressure goes up, you need hotter and hotter temperatures to melt the ice. But look at the red curve. That's the salty water. Notice how at any given pressure, the salty ice melts at a much, much lower temperature. Salt basically acts like an antifreeze, which makes it way easier for this high-pressure ice to exist in this kind of slushy, partially liquid state. And this salty slush, it has huge consequences. For one, it means liquid oceans can exist at way greater depths than we ever thought possible. But, and this is the big one for our magnetic field mystery, adding salt makes Ice VII electrically conductive. And a moving, conductive layer, well, that's the essential ingredient you need for a planetary dynamo. But wait, the physics gets even stranger. As the pressure builds and we go deeper, we see a transition from Ice VII to its even more extreme cousin, Ice X. Okay, let's zoom all the way in, down to the molecular level. In Ice VII on the left, the oxygen atoms are locked in place, but the little hydrogen protons are kind of wild, jumping back and forth between two different spots. But as you crank up the pressure to create Ice X, shown on the right, those protons stop jumping. They get forced into the perfect midpoint, creating this perfectly symmetric crystal. But here is where things get really, really wild.
The change from Ice 7 to Ice 10 isn't like flipping a switch where it's one thing and then snap, it's something else. New research is showing that it's a gradual, continuous crossover. It's a fade. The absolute best way to think about this is like a dimmer switch, not a regular light switch. As the pressure increases, the structure doesn't just snap from one state to the next. Instead, it gradually fades. It slowly dims the properties of Ice 7 while it brightens the properties of Ice X. It's this smooth, continuous transition. All right, let's put all the pieces together and bring this home. Section 5, powering an alien planet and finally solving that magnetic mystery we started with. So how do you actually build one of these planetary magnets? Well, it's kind of like a three-step recipe. Step 1, you start with a deep, salty ocean. Step 2, immense pressure crushes the bottom of that ocean into a layer of conductive, salty Ice 7. And then step 3, the planet's rotation and its internal heat get that conductive layer churning and moving. That motion, that's what generates the magnetic field. And that right there, that's the big picture. This bizarre salty ice isn't just some scientific curiosity. It's a potential engine for entire planets. It could be the answer to the mystery of our own ice giants. And by creating these stable, deep, liquid oceans, it could be a crucial ingredient in the recipe for finding life elsewhere. The universe is just full of materials that behave in ways we're only beginning to understand, and it's completely changing our search for life. If you found this as fascinating as I do, please hit that like button, and be sure to subscribe to Zero Facts for more explainers just like this one. Now, I've got a question for you. Based on everything we just talked about, what exoplanet do you think is our best shot at finding one of these hidden salty oceans? Let us know what you think in the comments. Thanks for watching.